Today's lesson, Tautomerism. What are tautomers? When a compound with a particular functional group changes spontaneously to another compound with different functional group and both the compounds remain in dynamic equilibrium, then the compounds are called tautomers, and this phenomenon is known as tautomerism. Let's see one example. Molecular formula is C3H6O. C3H6O. One tautomer is CH3CO CH2 here H. This is propanone. This is called ketoform. This compound changes spontaneously to another isomer with different functional group. This is functional group, ketonic group or carbonyl group. It changes spontaneously to another isomer with different functional group. The compound is CH3 COH double bond CH2. Its name is propene-2-ol. This is enol form. En from alkene and ol from alcohol. So this is enol form and this is keto form. One compound with particular functional group, that is carbonyl group, changes spontaneously to another compound with different functional group and both the compounds remain in dynamic equilibrium. Then these compounds are called tautomers, and this phenomenon is known as tautomerism. Now let's see how this compound changes spontaneously to another compound. Let's see the mechanism. This is propanone, which is keto form. Here electronegativity of oxygen is 3.5, carbon is 2.5. Because of the higher electronegativity of oxygen, pi bonded electrons move towards oxygen. Then oxygen becomes negatively charged and carbon becomes positively charged, and this carbon oxygen double bond becomes single bond. Because of this positive charge, these covalently bonded electrons move towards this carbon, and this carbon oxygen single bond becomes carbon oxygen double bond, and at the time this hydrogen is freed as proton, and after that this proton combines with this oxygen, positively charged, negatively charged. Now let's see what compound is found. CH3 carbon, this carbon oxygen double bond becomes carbon oxygen single bond. This oxygen combines with this hydrogen and alcoholic group is formed. This carbon-carbon single bond becomes carbon-carbon double bond, and then CH2. Now let's see how this compound converts to this compound spontaneously. Here electronegativity of oxygen is 3.5, hydrogen is 2.1. Because of the high electronegativity difference, these covalently bonded electrons move to carbon oxygen bond when these electrons move here, then there is created electrons repulsion here, and as a result these pi bonded electrons move towards carbon and it becomes negatively charged. And when these electrons move here, this hydrogen is freed as proton. This proton combines with this carbon. Then we get here CH3. That means CH2 another H. Carbon-carbon double bond becomes carbon-carbon single bond. Carbon-oxygen single bond becomes carbon-oxygen double bond. And this hydrogen goes to this carbon, that is CH2H. CH2H. In this way, tautomers are formed. Both the compounds remain in dynamic equilibrium. These tautomers are formed due to the shifting of this hydrogen to this oxygen and this hydrogen to this carbon. So tautomers are forming due to the shifting of hydrogen in the compounds. These compounds exist in dynamic equilibrium. These compounds are called tautomers, and this phenomenon is known as tautomerism. Let's see another example. Tautomerism between ketoform and enol form of phenol. Let's write the compounds. This is ketoform of phenol. Here these pi bonded electrons move towards oxygen and it becomes negatively charged, and this carbon becomes positively charged. Because of this positive charge, these covalently bonded electrons move towards this carbon-carbon single bond, and this carbon-carbon single bond becomes carbon-carbon double bond. And at that time this hydrogen is freed as proton. This proton combines with this oxygen. Now let's write the compound. Ketoform of phenol exists less than 0.1%, which is extremely little amount. Now the tautomer is this carbon-oxygen bond becomes single bond. This hydrogen combines with this oxygen. Then alcoholic group is formed. Here this carbon-carbon single bond becomes carbon-carbon double bond. Here one double bond, here one double bond. So this is enol form of phenol. This is a stable form of phenol which exists more than 99.9%. So these compounds are tautomers, in which both the compounds are formed due to the shifting of this hydrogen. This is all about tautomers. One compound with a particular functional group changes spontaneously to another compound with different functional group, and both the compounds remain in dynamic equilibrium. Then the compounds are called tautomers, and the phenomenon is known as tautomerism. No more. Thank you very much.